So hi everyone, welcome to our third and final individual seminar for the Race and Place seminar series for the CGA, Geospatial Graduate Student Organization. Today we have Dr. Jennifer Richmond-Bryant, and she is an associate professor of practice in the North Carolina State University Department of Forestry and Environmental Resources. Her research specialization is human exposure to air pollution with particular emphases on air pollution in underserved communities. Professor Richmond-Bryant is currently leading an exposure assessment of hazardous waste combustion emissions in a rural Louisiana town as part of the Louisiana State University Superfund Research Center on environmentally persistent free radicals. Additionally, she is collaborating with faculty at NC-A&T to develop a program for collaboration among students from both institutions. She teaches fundamentals of air pollution and the indoor air quality laboratory in the Environmental Technology and Management program and Environmental Law and Regulation and Air Quality Assessment for the Masters of Environmental Assessment program. She is also coordinating the Department of Forestry and Environmental Resources Diversity, Equity, and Inclusion Committee, and she joined NCSU in 2019, having previously served as an exposure assessment subject matter expert for the US EPA National Center for Environmental Assessment, and as an assistant professor in the City University of New York Urban Public Health Program. So we are very excited to have Dr. Richmond-Bryant here with us today, and the floor is yours.
Thank you so much. Thank you for the invitation. It's really great to be able to connect with all of you. I decided not to present the Louisiana State work because I presented that in October with the CGA for the monthly talk. I don't remember the exact name of the forum, but it was like the monthly forum that CGA has. And I thought, so some of you might have already had an opportunity to learn about that work, and I didn't want to repeat myself too much. Hopefully in another year, we should have some more interesting results to share, and I would be happy to come back at that point and talk a bit about that. But I thought for today, being a group that works with geospatial data, that this other branch of research that I've been working in the last few years might be interesting. And this actually started during my time at EPA. So I worked on a process called the Integrated Science Assessment, which put together all of the information that would be relevant to a type of air pollutant that's regulated under the National Ambient Air Quality Standards. But we also did some side work, and there were a number of us in this group who were interested in disparities in air pollutants and their impacts on communities in the country. And I had a couple of really engaged interns who were working with me during that time. Ihab Mikati, who I have in the first author slot, he's actually now a law student at NYU and getting ready to graduate and wants to be doing EJ law work in his career in the extended future. And then Adam Benson, who has an MPH in epidemiology and is just started working, I think, for the FDA actually, but has a really strong interest in disparate impacts and environmental justice as well. I also want to just give credit to three more people. Norman Urbanek, who is an undergraduate in the Environmental Technology Management program, who's been working with me for almost a year now. And I'm going to be sharing some of his work towards the end of the talk, as well as Tom Lubin and Jason Sachs, who are two of my former colleagues at EPA, who were also involved in this work. So the first part, I really credit mostly to the motivation and drive of Ehab, the law student I mentioned. And he really set this study up and got it off its initial feet. I'm very bad at metaphors, so I feel like I'm mixing a metaphor somewhere. But the study disparities in PM 2.5 emissions burdens in the US was really his passion project. And just before I actually go, I just want to point out there are a couple of papers that we published from this work that both came out in the American Journal of Public Health, one of which is from 2018 and one of which was published last year. So if anyone's interested, you can go find those. I'd be happy to share those with everybody at the end, and I can put those in the chat. Just making a note to myself to put those in the chat at the end. Please feel free to remind me if I forget by the time we get to the end of this talk. So the initial research questions for our work was whether PM 2.5 emissions basically burdened individuals living near sources differently among marginalized groups compared with non-marginalized groups. So marginalized being generally people of color, people of low income, compared with communities that were predominantly white and higher income. How do those burdens vary within states, counties, and urban areas? A few things that these studies do not, this particular study does not address is residential proximity to all other sources of pollutants. In this case, we were really mostly focused on, I'm just going to grab my pen. In this case, we were really focused mostly on PM 2.5 emissions from stationary human-built sources. So we weren't looking at roads, we weren't looking at other pollutants. And the reason we were focused on stationary sources actually is because they tend to come up in areas that are more impoverished, or more impoverished areas, communities of color tend to grow around those emissions due to combination of the history of redlining and just the fact that land is cheaper by those locations. We did not think about in this particular study causes of disparities. So we're really looking at the co-location of emissions with people, but not thinking about what caused them to be. This analysis is just not set up to do that. And we also did not look at health impacts. So what we did is we combined two sources of data, the National Emissions Inventory, and most of the first part of this talk is focused on 2011 data, looking at the EPA database for air emissions. 63,000 facilities reported PM 2.5 emissions. This database includes contaminants of 250-ish types, including PM 2.5 and PM10, and hazardous air pollutants and other criteria air pollutants are those that are regulated by their concentration under the Clean Air Act. And we combined those with the American Community Survey from 2009 to 2013, which overlapped with the 2011 National Emissions Inventory data. We also looked at other years, but I'm going to start by focusing on 2011. Well, actually, the second part of the talk will be a little more on the 2014 data. So how we joined the data is, if I can try to forward my slide, there we go. What we did is we used this approach called Centroid Containment. So we looked at a facility, and you can see that's given by the yellow star in the center. And whenever the centroid of a block group came within 2.5 miles of a facility, then that block group was counted. It's not a perfect system because there were some areas, like you can see here in white, that were closer to the facility, but not counted because the centroid was not included. Or there were also areas like you can see in this block group on the left, where they were further than 2.5 miles from the facility, but they were included because the centroid was within 2.5 miles. So this is not a perfect system, but it was the best system that we could come up with. We did try to test this by looking at different radii and saw very little difference between 5 miles and 2.5 miles. And so we decided to focus on those that were most proximal. So here are some of our results. We basically computed a population weighted average for the block groups by group for the emissions of PM 2.5. And that calculation is what we call the absolute burden. And we would do that for each group. So we looked at the overall population and then broke it down using our American Community Survey data by white, by people of color overall, Black, Hispanic, and then breaking it down by those who were living above the poverty line versus those living below the poverty line. And so the absolute PM 2.5 burden in tons per year was computed for each of those. We also see on the left column the proportion of the population made up by each of those groups. And then we can see on the left a proportional burden, which is the ratio of the burden for a specific group over the total population. And so when we compare for the non-Hispanic Black group, which had the highest absolute PM 2.5 burden of 34.5 tons per year, this was a little more than 1.5 times the overall population. And I believe this was about 1.8 times higher compared with the non-Hispanic white population. When you compare those above and below poverty to the total population, you can see that for those who were living below the poverty line, they were had about 35% higher burden than the general population. And it was about 1.4, 1.5 times those who were above poverty. I do want to say, so the absolute burden was 22.4 tons per year in 2011. If you updated the data to 2014, the absolute burden dropped to 19.1 tons per year. So it went down a little bit overall, and we see progress. And we'll get into some reasons for that progress in a few minutes. So looking at the absolute burden by subgroup, first we can start off looking at the absolute burden as a fraction of population for the entire population. So this is basically a cumulative distribution of all of the counties in the US. And you can look at how they were distributed from the 0th percentile fraction of the population all the way up to 100% of the population. And we can see the PM 2.5 burden on the y-axis, and this is a logarithmic scale. So here's our overall population. It's skewed by high polluting facilities, so the mean is actually around the 85th percentile. So let's look at what happens when we factor in different population groups. And so the same black line representing the overall population is found in the middle. And you can see a pretty clear schism where those living above the poverty line versus below the poverty line, whose distributions are shown by dotted lines, fall on either side. Likewise, those of white race compared with those of Black race on the green line, or those of Hispanic ethnicity of any race in the orange line, show some pretty large disparities in burden. So some of the data are shown here. 2.9 tons per year among the Hispanic community compared with 0.1 ton per year for the 50th percentile of the population. So 50% have lower burdens, 50% have higher burdens at this point. If we look at the 80th percentile for each group, uh, among the non-Hispanic white group, the burden was 8.7 tons per year. For the Black group, it was 21.8 tons per year. So, pretty substantial differences are seen among the groups. We can break this down by geographic arrangement to see just to state when we looked at these data, these are nationwide. And then going forward, we can break it down by state and county. And that starts to allow us to drill down into the types of areas that might be impacted. And surprisingly, one of the highest areas in the country was actually Indiana. Alabama was not quite as surprising because there's a lot of industry in the Birmingham area compared with Indiana. But you saw the most burden among people of color in Indiana. So why is that? And when we break down, and just to point out, you can see a county level map on the right. If we break down the data by urbanization, that doesn't tell the whole story. We can see the Indianapolis area circled and the area of Gary, Indiana, which is just outside of Chicago, circled. And the burden among people of color for the urban areas of Indiana was about 1.8 times the general population. The burden for people of color throughout the state was 2.1. And so urbanicity did not necessarily account for these disparities. We can see here, this is the county level map in the southeastern corner of the state, and this eastern county within the state, that there were some pretty high disparities among people of color. So what's driving those disparities? We don't necessarily know outside of race itself. Just moving a little forward with this, if we compare the total population and then break it down by RUCA code, RUCA is the rural urban commuting area, we can see that the patterns generally hold. So for all areas of the US, you can see that the highest absolute burden was for the non-Hispanic Black community, and then the Black community, and those of low income. So then when you break it down, 1 is the most urban, 4 is more like micropolitan areas, and 7 is small town core areas. You can see that the patterns generally persist where burdens are highest among Black communities for each of these types of areas. So it's not necessarily just an urban problem. In more rural areas, the economic disparity seems to disappear that you see in small cities and large cities, but the racial patterns seem mostly to hold. So the conclusions of this part of the work are that burdens due to PM 2.5 emissions are high nationwide among people of color and people living below the poverty line. Burdens were highest among non-Hispanic Black residents of the US compared with all other race ethnicity groups and compared with those living below poverty. Race ethnicity disparities are therefore not explained just by poverty, and these patterns hold among urban and rural areas, And so these disparities for PM 2.5 burdens are not necessarily an urban-rural problem either. And so after this, we thought it would be interesting if we looked at how this type of analysis could be applied, thinking about some policy changes in the US. And so we looked at changes in PM 2.5 emissions burden disparities related to coal-fired power plant closures. And so I mentioned earlier that one of the classes I teach is an environmental assessment class on law and regulation. And so I want to actually draw from that background just a little bit and talk about talk about climate policy in the US related to air pollution, and then think about how we can analyze that through a disparities lens, if that makes sense. So, little background policy-wise. In 1998, Representative Tom DeLay from Texas asked Administrator Carol Browner if the EPA, so she was the EPA administrator at the time, if the EPA had authority to regulate greenhouse gases as a criteria pollutant. The EPA General Counsel then wrote a legal opinion that two conditions needed to be met for this to happen. Greenhouse gases would have to meet the legal definition of a criteria air pollutant, and a criteria air pollutant is one that's considered so ubiquitous that we regulate its concentration. PM 2.5 that we just talked about is an example of a criteria pollutant. We would also need what's called an endangerment finding, where greenhouse gases were found to endanger public health or welfare. And if you go back, 20, 25 years, the scientific community was not united around this concept just yet. So in 1999, 19 organizations petitioned the EPA to issue the endangerment finding for greenhouse gases. They did not yet. And so they coalesced, these 19 organizations, behind the state of Massachusetts, which initiated the lawsuit. And there was a Supreme Court ruling 10 years later on the matter. In the Supreme Court ruling, it was a 5-4 ruling where the justices determined, the majority determined, that the EPA was obligated to regulate greenhouse gases, or at least to look further into their reasoning for it. EPA, they said in quotes in the case, has offered no explanation for its refusal to decide whether greenhouse gases cause or contribute to climate change. Their failure to regulate is arbitrary and capricious, or I should say, I think I misstated that actually their failure to evaluate fully whether greenhouse gases should be regulated is arbitrary and capricious. So it was remanded or sent back to the EPA for further clarification. These are the 5 justices who ruled in favor of remanding the standard. So at that time, there was a change in administrations, and on December 7th, 2009, so not too far after that case was decided, Administrator Lisa Jackson of the EPA signed a memo regarding greenhouse gases that basically assigned an endangerment finding, that greenhouse gases threaten public health and welfare, and that we had enough evidence of it at that point, 10 years after this group coalesced to dispute EPA's policy, that they made this endangerment finding. And so one of the major pieces of regulation during the Obama years was the Clean Power Plan from 2015, which was finalized in 2015. The EPA established interim and final CO2 performance standards for coal-fired power plants and natural gas power plants. So a performance standard means basically how much these facilities can emit and considering different technological innovations that need to be pulled in for that to happen. This regulation was issued under the auspices of the Clean Air Act. It was authorized by the Clean Air Act, and states had latitude for how they would actually enact these regulations. They could use a best system of emissions reduction, so that a system that makes sense in North Dakota might not be the same system that makes the most sense in New Mexico. Emissions reductions were supposed to be phased in between 2022 and 2030. And when the Clean Power Plan was on the horizon, so even before 2015, many coal-fired power plants began moving operations to cleaner burning fuels. Part of that was driven by economics, because natural gas is a lot cheaper than coal and fracking became more prevalent. Part of it was knowing that regulations were going to be tightened more in the future, and so they wanted to be ahead of that curve. And as a result, a number of facilities closed within that time period from like 2015 to 2018. So some research questions we can ask are, how have PM 2.5 emissions burdens declined in the US due to closures of coal-fired power plants? And then getting back to our spatial analysis from the first part is, have emissions reductions been equitable? And so we used our burdens analysis to try to explore that question in some different ways. So the first thing we did was review energy information administrative reports, which come from the Department of Energy for 2015, 16, and 17, to identify coal-fired power plants that closed over that time, and 92 were found to have closed. We linked that information about closing facilities to the 2014 National Emissions Inventory, calculated the PM 2.5 burdens specifically due to that segment of the economy, fossil fuel-based power plants, and then we recalculated those burdens, removing those 92 plants from our assessment. Then we simulated the impact of closing 92 facilities at random to compare those that closed at random across the US with the 92 that actually closed, to see if there were differences among each demographic group that we had looked at. And we compared the PM 2.5 burdens for census block groups that were in the top quartile for race, ethnicity characteristics, and poverty characteristics, to see if we could learn a little more about those who are especially impacted. So we can see on the left is a map of the US, and there's kind of a lot going on in this map. So we've got these concentric circles at each of the 92 facilities that were closed. The size of the circle indicate the tons of PM 2.5 that were emitted by the facility. The inner circle indicates the proportion of people of color who were affected by the facilities. If it was on the purple side, it was an area that had a lower than the proportion of people of color in the US. If it was on the orange side, it had a greater proportion than average for the US. Likewise, if we look at the outer of the concentric circles, a circle that's more purple is more those who live above the poverty line, and a circle that's more brown is more, or orange, more below the poverty line. So just to give you an idea of how this is set up. And what we learned from this part of the analysis is that most of the closed coal-fired power plants were in areas with high poverty and majority white areas. And that was not super uncommon for the areas in, say, Western Pennsylvania and Ohio and Indiana, where a lot of the coal-fired power plants have operated. So we asked the question, are the burdens equitable? And so again, what we did was this kind of Monte Carlo analysis where we looked at the burdens from the 92 facilities that we closed, which are indicated by these black circles. And we compared them both to the 2014 condition, which is an open square, and to the simulated removal at random of 92 facilities, which are the open circles. And you can see proportional burden is on the left and absolute burden is on the right. I actually should have made it the other way around, but didn't have a chance to change that. I'm actually going to just remove the pen marking just so you can see this a little bit better. And so let's start with absolute burden on the right, where we can see, and this is a success, that overall, and for every group from 2014 to 2017, when these facilities were removed, that burden went down. So that is a victory. So regardless of anything, we want burden to be going down for all groups. Absolute burden was released for all groups, economic as well as race ethnicity groups. But then when you look at proportional burden, what happens is for people of color, the proportional burden actually went up compared with the general population. I want to point out one thing that's a little tricky to illustrate, but when you break it down by Black or Hispanic alone, and I'm actually kind of leaning into C, you can see here, I'm just going to draw vertically. I'm not drawing this vertically well, but let me try that one again to make a straighter line. If we draw this line vertically from 1, which means that the burden is equivalent to the general population, what we can see is actually for the Black and Hispanic groups that the proportional burden for the coal-fired power plants was lower than 1, which is good, but that the proportional burden was creeping up. So anyway, it's a trend to watch to try to understand. One other thing I want to point out, though, is that these gray bands are the 95% confidence interval around the simulated burden from removing 92 facilities at random. And in every case, with the exception of the proportional burdens for people of color and for white proportional burdens, in every other case, the proportional burdens from the 92 actual facilities closed fell within the bands of the distribution when those were closed at random. So it's not showing that there is a large disparity in this case. But if we try to dig a little further and look at those who kind of suffer from intersectional stresses, looking at the intersection between the top quartile for people of color versus the top quartile for those above or below poverty, the top quartile of those who are Black, thinking about those who live in areas with the top quartile above or below poverty, we can start to see some patterns. And so the dashed lines have to do with below poverty, and the solid lines are above poverty. And then the colors of the lines indicate race ethnicity groups. And so we had basically could see a disparity where those below poverty always had a greater burden when they were in that highest percentile intersection, um, compared with the general population, which is the solid black line. And those above poverty always had lower burden than the overall population. We can also see, though, that maybe some trends were emerging where the facilities were closing around white areas, which is given by the blue dashed line, faster than for areas that are predominantly non-Hispanic Black, areas that are Hispanic or people of color, compared with those who were white. So that trend is something that we can watch over the years as we continue to analyze these data. So conclusions of this part of the work include that closure of coal-fired power plants reduce PM 2.5 burdens for all groups. That's a good thing. I can't emphasize that enough. For fossil fuel power plant generated PM 2.5, poverty appears to be the most important determinant of burden, and disparities in burdens due to fossil fuel power plant generated PM 2.5 appear to be shrinking, but possibly with more benefit to predominantly white neighborhoods right now. So trends to watch. Just a little side note on the policy. We can see this kind of joyless crowd on the right who were signing the Affordable Clean Energy Rule in 2019 with much lower carbon dioxide targets. When I say much lower targets, I mean lower reduction targets. So the policy sought less reduction in CO2. On January 19th, 2021, the DC Circuit Court vacated this policy that was signed here. So this was the Affordable Clean Energy Rule. And they remanded it to the EPA because they stated that the policy is still required to fulfill Massachusetts v. EPA from 2009, and they did not believe that this new policy did so. On February 12th of this year, the EPA issued a memo stating that the agency is unlikely to reinstate the Clean Power Plan, and that's largely because specific dates were written into it. And those dates are now not realistic because it's 2021. And so states don't have enough time to issue plans by 2022. But a policy similar to the Clean Power Plan is more likely to emerge in the next year or two based on the current administration's stated policies. And I do want to point out, I'm not saying that to advocate for one political group or another, but that the policy sides of each group are clear and they are what they are. So I just want to talk a little bit in the last few minutes of this talk about disparities in hazardous air pollutant emissions burdens in the US. This work is in progress. It's being led by Norman Abanik, who is an undergraduate student working with me right now. And so the research questions that we had, going back to the burden work that EHAB had started earlier, is residential proximity to hazardous air pollutant emissions from stationary human-built sources of air pollution disproportionately greater among marginalized groups? Again, we look at specific sources because real estate decisions are made around specific sources. I mentioned very early on, or actually Ian mentioned reading my biography, that I've been doing some work in Louisiana, and there is what's considered the industrial corridor, or has also been known as Cancer Alley, it's about a 90-mile stretch between Baton Rouge and New Orleans that is dotted with petrochemical facilities. And some of the chemicals that we're going to talk about in a second are known to be generated at these locations. So we're going to look at if those disparities exist. And question about how those vary within states, counties, and urban areas is one that we are working on. I do not yet have those results to share with you, but that is a research question we're focused on right now. So for nationwide results, I selected 5 respiratory hazardous air pollutants to look at. And these are the proportional burdens. I'm sorry, excuse me, these are the absolute burdens in tons per year, which I did not state, but these are in tons per year. So burdens of about 3,200 pounds per year for the overall population for formaldehyde, 477 for acrolein, etc. And then we can look at how those are broken down by race ethnicity group. And we can see here that for 4 of the 5 contaminants, that the burdens are highest for non-Hispanic Black individuals, for non-Hispanic Black communities. And the ratios between the highest group and the overall population are given in this bottom row. What's striking is that for chloroprene, the risk to non-Hispanic Black communities is 4.5 times that of the overall population, and a little more than 7 times that for non-Hispanic white communities. And this is a compound that is very important to that area in Louisiana, where there's so many petrochemical facilities. So our findings so far is that for most of the hazardous air pollutants we've evaluated, emissions burden is highest among non-Hispanic Black people, that disparity is more than 7 times between non-Hispanic Black and non-Hispanic white groups, and the burden is also higher for those living below the poverty line compared with those living above poverty. So overall messages from this work are that joint exploration of data sets for pollution and demographics can reveal disparities in emissions burdens, can reveal disparities in what people are exposed to and how different groups are exposed. And these disparities based on race, ethnicity, and poverty level are apparent. And that is all I have. So I am happy to take questions. And I thank you for the invitation, for your time.
Thank you for that presentation. So yeah, we have about 13 minutes. If anybody has any questions, I can start off with one. I was wondering, you focused on PM 2.5, and I remember reading from previous research that PM 2.5 is known to be like a major, it's one of the most well-known pollutants. And I was wondering, is there a specific reason other than that you focus on 2.5 as opposed to PM 10 or another one?
Well, so PM 2.5 tends to get deep down into the airways, and there is a preponderance of literature that has shown that PM 2.5 has what's known as a causal relationship with mortality in short-term exposures, as well as with cardiovascular effects. So when the PM 2.5 work started in around like 2017 or so, we were at the EPA, and this is when I still worked at the EPA, we were in the process of working on the integrated science assessment for particulate matter. And that assessment looks at both PM 2.5 and PM 10 minus 2.5, which is coarse PM. When I say 10 minus 2.5, that's because PM 10 actually includes everything smaller than that, including 2.5. Coarse PM is a little larger, and so that when you inhale it, can make its way down to your upper airways. But PM 2.5 is small enough that it can actually navigate the turns to get down into your alveoli. And that's why the health impacts of exposure to PM 2.5 tend to be more important. Now, it's not to say PM 10 is not also important. If you have something that gets down into your upper airways, it can be a trigger for asthma, and there are other things like throat cancer or nasal cancers that can come about from exposure. But it tends to be uh, less dramatic than something like mortality associated with PM 2.5. But part of it actually was also because we were working on that assessment at the time.
Thank you.
I also just want to note Nikki Inglis had a comment that she typed into the chat. She said she really appreciates the extensive policy context. Oh, well, that's very nice. Thank you. It's so very helpful in understanding and interpreting the work. I wish more scientists shared this level of context. Oh, that's really nice. Thank you. Sorry, I probably should have read it before I read it out loud, but that was a really kind comment, so I appreciate that. Are there other questions or comments?
Hey, Jen, can I ask you a question?
Sure.
So I have to agree with Nikki. Thank you so much for your presentation. I mean, it's really interesting just to see this kind of work as well. With some of your work, you did identify that low income, poverty, as well as people of color do tend to live in some of these more heavily burdened areas. Can you draw any kind of relationship as to why people are located where they are in such more riskier areas? I mean, is it because of the work? Is it because of the employment demand and those sorts of things?
That is a great question. And I did say in the beginning of the talk, and I think this is an important distinction to make, that this study is not designed to elucidate reasons. Mm-hmm. So because of that, anything I say is, I don't want to say speculative, because I think that we can think about reasonable ways that this happens, but it's not something that we studied specifically, so it's not based on our results. I would say if you're thinking about where people live compared to these facilities, this really ties into things like redlining, where people of color were shown to live versus people of non-Hispanic white backgrounds, back in the days and even now, so there are now historically Black communities that are built up around these areas. You also have then, so in Louisiana, for instance, in that industrial corridor area that I mentioned, the area that was along the Mississippi River between Baton Rouge and New Orleans was lower lying land. It was cheaper land that people took ownership of, after slavery and took for their own. And facilities, industrial facilities, ended up purchasing land there because it was cheaper, and because, and this is, while I'm saying this kind of speculatively, I think this is probably a fair statement, that they anticipated less community resistance compared with, well-heeled communities. And that included all of the racial implications as well as the economic implications of that. And oftentimes, communities of color do tend to be poorer communities as well. But one of the interesting things that did actually come out of this work was that it wasn't just obvious that it was an income related phenomenon.
Thank you for being pushed out there to speculate.
Oh, sure. And I say that more because I think it's important, especially for students, to hear that we can sort of think, well, okay, common sense, when we think about the history that we know, that some of these things might be the case, but then we also have to be mindful of the limitations of our study results. And so in a paper, I can point out the relationships that I observe. But if my study is not designed to say why, I can't necessarily speculate. But, one could use this kind of work to then ask other questions and try to design experiments that are more causal, looking at things like trends over time sometimes help to establish more of a causal relationship between one and the other. Looking at historic documents sometimes can help to establish causal relationships. So there are other ways that people can try to do this, thinking about policy analyses. May help to answer some of those questions that this particular study was just not designed to address.
Thank
Other
you.
questions? Sure. Well, if there are no other questions, my cat is at the door meowing that nobody is letting him in. So I'm happy to take other questions. I'm also happy to run up and open the door for him before he is about ready to scratch my eyes out. Are there other questions? I guess that's the downside of working from home. Well, I appreciate the invitation. Thank you so much for your time. And I'm looking forward to finding other ways to interact with everybody in the future.
Of course. Thank you, Dr. Richmond-Bryant. And for those of us still here, just a reminder that we have our final event for the Race and Place seminar series. It will be a panel on the 14th of April, and we will be sending it out an email for that soon. Thank you.
Great. Thank you. Have a nice day, everybody.